It's going to be on chapter 1 on Brookshire, the computer science book, chapter 1 and 2 on the Savage C++ book. If you don't know what is in there, go take a look at the book. Yes, sir. It's got multiple choice. It's got the segments of the programs that you're going to do debugging. So it's basically everything in the book. If you have not read the book, it's time to start reading it. Any other questions? No questions? Yes, sir.
By using the computer or just syntax?
Syntax error. Yes. Or it's going to have a segment that says, okay, if I is this one, what is the result of this code when it runs? Any other questions? So we have some leftover of chapter 2 that we're going to cover, and then we're going to go on chapter 2 of the computer science book. We are not going to finish that one. We're going to continue on Wednesday. So we talked about 2.1, 2, 3. Now we're talking about simple flow of control. Okay, before you start writing your program, you're supposed to read your book. You want to get to understand what's going on before you start writing your program. I had some people asking me questions, seemed like they didn't know what's going on in the book. If you have a question, you got to ask. But please do read your book. So we're checking to see if the hours are greater than 40. We're going to do something else. We're going to do something else. We did go over these things. So we're going to have if a Boolean expression. That means it says they're true or false. If it's true, we're going to do this one. Else, we're going to do something else. We went over these things last time, right? So we're going to have the or. It's going to be either one of these is correct. Then we have not. Not is going to change whatever is in there. So if this is true, it's going to be false. If it's false, it's going to be true. Even though it's a good, important thing to know, down here it says operator can make expression difficult to understand, use only when appropriate. So if you don't have to use it, don't use it. Especially if you have a mix of or and you put a not under, things are going to be a little different. So we've got to watch for those things. Another one, this is going to be a good question in the test. You cannot use if x less than y less than z. You have to use the and. So it's going to be if x less than y and y less than z. Once again, we cannot have the one single equal sign for comparison. That's the assignment. So if I use x equal 3 by mistake, that's going to be always true. This is the comparison, 2 equal sign. If I have one statement, I do not need braces. If I have multiple statements, I'm going to use the braces. Now we're getting to while loop. Okay, while it's going to be, so we're going to be using the while if we have a continuous loop. So for the ones that you have 10 numbers, you're going to be using a while loop instead of doing them one at a time. So instead of having 10 variable, you're going to have while loop using the same variable over and over. So the one in the problem in your book that's asking for 10 numbers, you are not going to define 10 different variables. You're going to only define one variable, and you're going to use the while loop to do that. So how are we going to do that? We're going to have set, check, and change. So we're going to have set, check, and change. So set is going to be before while loop, check is going to be during the while loop, and change is going to be inside. So before we have to set it, then we're going to check it, and then we're going to change it. If I put a semicolon over here, that's going to make things go wrong. It doesn't give you an error. It's going to just stay here forever because it's not going to change anything. The do while is back upside down of a while. It has a semicolon over here. This will guarantee that this statement is going to happen at least one time. The while loop, if the condition is not correct, is not going to execute at all. From the software engineering point of view, the recommended way of doing it is while loop. So if you look at the display, we're going to have a do and a while. This is going to be good for because it's guaranteed that's going to happen one time. So if you're using a question about do you want to continue the program, this is going to be a good one to do. If I have only one statement, I do not need braces. So this is the one that you're going to put it in your program to ask the user if they want to continue. That is display 2-14. So it's going to be do. We're going to ask a question. Do you want to continue? We're going to read in as an answer, and then we're going to say while answer equal single y, either uppercase or lowercase. Then we're going to go back. So while the answer for the user is going to be single y and y is going to keep continuing. I could initialize this answer to be one of these, and then I would have my while loop normal way. So I would set my answer to y, then I would have a while loop over here, and then I would do this, and at the end it's going to go back and it's going to ask the question again. We have increment and decrement. So we have a plus plus and minus minus. X plus plus is going to add 1 to x. It's going to be x equal x plus 1. X minus minus is going to be x equal x minus 1. So somebody asked me about this and I said it's not in the book. That's where it is. So we can have a plus plus at the beginning, minus minus before that. If it's going to be after, it's going to use this number and then it's going to add 1 to it. So if I have a complex expression and I have a number here plus plus, it's going to use that number and then it's going to add 1 to it. If it's going to be before that, it's going to use the add 1 and then it's going to use it. So this is a sample program it's talking about. The bank charges card balance of $50, 2% per month interest. How many months without the payments before your balance exceeds 100? So what is the condition I'm going to put in the while loop? Less than what?
100.
Less than 100. What is less than 100?
99.
The balance. So I'm going to set the balance to 50. I'm going to check it to see if it's less than 100. In here, I'm going to keep changing my balance, and eventually it's going to get to 100. That's going to stop. So I'm going to set it, I'm going to check it, and I'm going to change it here. Another way of using while is going to be, say, not equal 12. So what's going to happen if I do this condition? I'm setting it, I'm checking it, and I'm changing it. What's going to happen to this?
After 6 times, it'll stop.
What else? It never stops. This loop is never going to stop. It's going to start with 1. It's going to do cout 1. It's going to add 2 to it. Now my x is going to be 3. Is 3 not the 12? That's correct. 3. Then it's going to be 5. We're checking 5. Then it's going to be 7. Then it's going to be 9. Then it's going to be 11. Then it's going to be 13. Then it's going to be 15, 17.
You change that to equals 13.
Good. Now, what we want to do is, instead of checking for one number, we want to use less than or greater than. Because that way we don't have to worry about jumping over a number. When we're looking for exact number, the chances of we're going to jump over it is high. So what we're going to do is we're going to use the less than or greater than to be sure we are not going to jump over that number. So if I set it to 10, while x is greater than 10, I'm going to deduct 3 out of it. What's going to happen to this one? First term is 10. Then is 10 greater than 0? Yes. I'm going to print 10. 10 equal 10 minus 3, which is 7. I'm going to go back. Is 7 greater than 0? Yes. Print 7. 7 minus 3 is 4. 4 greater than 0. Then we're going to print 4. 4 minus 3 is 1. 1 is greater than 0. We're going to do this. Now we have 1 minus 3, which is negative 2. Is negative 2 greater than 0? No. We're going to break out.
How do we stop if I say 5? So the loop, we can't do anything to stop it?
Well, that's going to stop. This condition, okay, the question is, what can we do for this loop to stop? When the condition changes, this condition is what? X greater than 0. When that changes, so in this case, when it's going to be negative 1, negative 2, that negative 2 is not greater than 0, it's going to stop. We're checking this condition. And if this condition changes, then we're going to stop. So every time it's come back here, it's going to check. If it's true, we're going to continue. If it's going to be false, we're going to get out. In what condition this is going to be false? The negative number. Yeah, as soon as x becomes negative number, this is going to be false, it's going to stop. Okay, we're going to talk about the program style, and we're going to start enforcing this from now moving forward. The idea of the program style is easier to read, easier to correct, easier to change. So one of the things that we have to be careful is we're going to be indenting everything in for easier reading. So when we have a group of code, we're going to group it and we're going to indent it. So right now I know this statement is belonging to this if statement. We talk about the comments. We have 2 lines that's going to comment from here to the end of the line. Or we can use a slash star, a star, a slash to finish it if we want to do multiple lines. We can potentially put 2 slashes on each lines over here. So I would put 2 slashes, 2 slashes, 2 slashes here instead of this. So either way is going to work. So now what we're going to do is we're going to put some comments inside of our code to make our code more user-friendly or the programmer-friendly, so we can understand what's going on. So we're talking about the constants that's going to be used in our program. So we have the name number constant, so they have a meaning, and we're going to simply by changing the value of the constant. So one of the things that, for example, we did in year 2000 we had to go and look at all the programs that they had 2-digit number. Then we had to read the code to be sure that 2-digit number is for the date. And if it was for the date, we would add 19 to it. But if we had some kind of a constant defined, then we could actually do it one time on top of the program. The other part of it is when it's a constant, nobody can change it inside the program. The convention is we're going to put it all caps. So I'm going to use the word const int all caps equal 10. Then I'm going to use this variable inside the programs. So if I decide to change this variable, I'm going to go to one place, change it, all of them is going to happen. So if I, for example, if I have a tax rate for 8.5, and then sometimes it's going to change from 8.5 to 8.6 or 9, then I have to go through all the codes that I wrote and change all the 8.5 that belongs to the tax, because I could have some other ones too, to change it to 8.6 or 9. But if I define it as a constant, all I have to do is go from 8.5 to 8.6. Everything is going to be done in my program. I don't have to go through my programs. So from now on, this is the format you're going to turn in your programs. If it's not like this, you're going to be deducted points. On the top of your program, you're going to have some description about what is the program, what is it doing. This is display 216. So you're going to do it exactly like this. You're going to have some explanation on the top, some information about the program, and you're going to have a sample run on the bottom. So on the description, you're going to put your name and the description of what the program is doing, and then on the bottom, you're going to have the sample run. Now in this one, I have a const. I have a double normal equal 98.6. Then I put 2 slashes here. I'm going to do some kind of a comment in here. Because these programs are small, maybe some of these comments doesn't have too much of meaning, but then here we're going to have some kind of a description, or we're going to define what we're talking about. Any questions so far? So how do you create a named constant of type double? You're going to be doing this. Let's do this. So we're going to put CONST and a space and a double, and we're going to call it something equal what? A number that has to have a decimal number, right? Good. Okay. So the second one, it says determine if a program can modify the value of a constant. Somebody in the back row over there. Are you with me? Okay, give me the answer for number 2. Programs cannot modify the constant. So if it's a constant, you cannot modify it. If I do it by mistake, I'm going to get a compiler error. The benefit of comments, somewhere in the back row over here. Yes, sir. To explain shortly what's happening right there in the program. Very good. Explain why indenting is important in a program. It's easier to read, easier to identify what the block of code is. Why the blank lines are important. Explain why blank lines are important in the program. So we're writing the program, we can write it all at the same time, or we can put some blank lines between them. So it's not easier to read, yes. So it's going to be easier to read, we can identify the blocks of code, so we can use those schemes for... That was end of chapter 2. So we're going to go to Okay. So this is chapter 2 in Brooksheet. We are not going to use this in the test, but the next test definitely going to have it. So we're going to talk about the computer architecture, machine language, program execution, arithmetic, logic, instructions, communicating with other devices, and other architecture. Who knows what the CPU means? Central Processing Unit. What does the CPU do? What does the CPU do? That's good. You're reading it right now. You have the right page in front of you. It fetch and execute instruction. CPU does not think. CPU does not do anything beside executing instructions. So now we're going to talk about those. What are we talking about? We have a arithmetic logic unit. So we would have a CPU which is going to be doing instructions. So we have some registers next to the CPU. We're going to move the stuff that we have in the RAM. What does RAM means? Random access memory. What does that mean? It's not sequential. What does that mean? Randomly can go to any access and pick up anything he wants. So if my program is going to be in this section, I can go in there and pick up an instruction, and I'm going to take that instruction, I'm going to put it in a register next to the CPU for CPU to execute. So if I have a 32-bit machine, my instruction is going to be 32-bit, my register size is going to be 32-bit, so I'm going to be moving 32-bit of my program to the register, and the CPU is going to execute those things. And because the CPU is the most important part of our computer, we're going to try to not make it too busy, and that's the reason that we have something else created. We call it ALU. ALU is like a CPU in a smaller portion. All it does is going to do the arithmetic. In a computer, it doesn't know the negative. It doesn't know multiplication. It doesn't know division. All of these things are going to be accomplished by adding and shifting. We're going to learn more about those things. So if I want to add, if I want to subtract a number, it's going to do 2's complement. That's going to be what? A negative number. And then it's going to add it to the other one. So that's the way we're going to add a positive to a negative, which is the same as subtraction. We do something like that in the multiplication. So it's going to be a lot of work to do something. I mean, let's say 3 times 5. It looks like a simple thing to us, but it's going to be a lot of work. So those are going to be passed to ALU. So the way that we're going to be passing the information, if I only had one line between the RAM and my registers, it would happen, what, 32 times to move 32-bit. So what they're going to come up with, what they did come up with, is they put 32 lines. So in one instance, I'm going to be moving 32 bits from the RAM to the register in one instance. So that's the bus. So if my bus speed is slow and I cannot move the information from the RAM to register fast enough, the CPU is just going to be sitting over there doing nothing. So I can have the fastest CPU, I can have the fastest RAM out there, but if my bus is slow, then the information is not going to be moved and the CPU cannot do anything because it doesn't have anything to do. And another thing is every program is going to take a space in the RAM. So if I'm running only one program and it's going to use this much of a space in the memory, so I go increase my memory double size, it doesn't matter because I'm still going to be using the same amount of the memory. So the program is going to come into the memory, it's going to use a piece of the memory. Usually if you look at the program, any kind of a program, if you're buying it off the shelf, it's going to ask for the minimum memory requirement, and that's what it needs to run it. So when we create programs and we put them in the hard drive, which is right now the slowest things in the computer because it has moving parts. Of course, we are moving to solid state, which is electronic, like a flash drive type of thing, which doesn't have the moving parts, so it's going to be much faster. The problem with RAM is what? If I turn off the computer, everything's going to go away. So we cannot have a hard drive like a RAM because it's going to go away. So the hard drive is cheaper than the RAM. RAM is cheaper than register. That's why we have less of a register, less of RAM, much more of the hard drive. Any questions over here? So we're putting all these things on a motherboard. Questions? So we have the control unit, CU or CPU. We have the ALU over here. We have the registers next to it. So putting all these things together, we're going to have the central processing unit. And then we have the main memory, which is going to be connected to the bus, and it's going to be moving the information from the main memory to the central processing unit. So remember, everything in the computer is zeros and ones. So when I have a program, especially in C++ and the C, when we create the final program, it's going to be in a binary code. So all this binary code is going to go to register, and the CPU has to know what to do with those codes. So some of you who is going to go to computer science, computer engineering, or electrical engineering, you're going to take assembly language, going to be looking at this a lot more detail. We have two systems about how we're going to do all this instruction. One is called the RISC, Reduced Instruction Set Computing. That is few, simple, efficient, and fast instruction. It was for Apple, IBM, Motorola, PowerPC type of thing. And then we have CISC, which is many, convenient, and powerful instruction. That's Intel. So it's a different way of the instruction set and how it's going to work. So data transfer is going to copy data from one location to the other one. The ALU is bit pattern to compute the pattern, and of course the control direct execution of the program. So if I want to add the two numbers, what do I need to do? Remember, everything is going to be in the memory right now because we moved some of it from the hard drive to memory. So if I have two numbers, first I have to get the first number and put it in a register. The CPU is just looking at the registers, so I have to put it in a register. So the next number is going to go next to another register. We're going to add these two numbers, and we're going to put it in the third register, and then we're going to take that register, the result, put it back in memory. So if I want to divide values, I'm going to load a register with a value. That's moving it from the memory to a register. I'm going to load another number to register, and then I'm going to check it to see if it's a 0. If the second number is 0, I cannot divide by 0, so I'm going to jump to down here. If it's not 0, I can divide it. I put the result somewhere, and then I'm going to put that result back to the memory. So we have load, that's putting it into register. We have jump, that's going to jump outside of this. We have divide, and we have the store, which is going to put it back in the memory. I have two numbers over here which are hexadecimal. How large is hexadecimal? How many bits? Hexadecimal is going to be 4. See what happens when you're on Facebook? You have good answers. So 4 bits and 4 bits is going to give me 8 bit. This is going to give me 1 byte, right? But so this is going to give me 1 byte. But because this machine that we're working on is a 16-bit machine, it's going to use 2 bytes to do whatever it needs to do. So I have registers over here. I have register 0. We always start with 0, 1, 2, all the way to F, which is what? 15. So for a 16-bit machine, I'm going to have 16 registers, typically. I have a program counter. I'm going to have instruction register. Instruction register is the current register, current instruction that I'm going to be executing. Program counter is going to have the address of the next instruction. So if I have a 16-bit machine, so I have it over here. So this is going to be, this one and this one is going to be 2 bytes. So my next address is going to be what? This one, right? So I'm going to be using 2 bytes for 16-bit. So from 0, I'm going to go to 02. So my program counter is going to have 02. My instruction set is going to be the value of these 2 together. So we have an opcode and we have an operand. Opcode is basically kind of a code that's going to say to the CU what are we going to be doing. And the operand is going to be whatever we need to be doing on it. So if I have, how many bits is this? 16-bit right here. So we have 16 bits. So the first 4 is going to be my opcode. It says 0011. So the CU knows what is this about, and then it's going to have these operands that's going to apply it to those things. So in this case, if you go to Appendix C in your book that we're going to be practicing for this this chapter, the 3 means store. A store, remember, is going to take it from somewhere, one of the registers, put it back in the memory. So where is the value that I have that I want to put it back in the memory? It's on register number 5. So it's going to go to register number 5, and whatever value is in register number 5 is going to take it and it's going to put it in this address. What is that address? A7. This is the Appendix C in the back of your book that has some code in it and it's telling what to do, and it has some example on it. So load register 5 with the bit pattern found in the memory cell. One of them is wrong over here. One of them should be the value, the other one should be the bit pattern. This is for the add, this is for a store, this is for halt. So we have machine cycle, which is fetch, decode, execute. So the CU that does only this. CPU is going to be doing this. It's going to fetch, meaning bringing from the memory to register. We're going to decode it. We're going to look at it to be sure it's okay, and then it's going to execute. So that's the cycle we're going to have. Retrieve it, retrieve the next instruction from the memory to register, put it in there, figure out what we need to do, execute it. That's all is going to be happening. Some people think about it as a brain. I don't know. Some people think that the CPU is not thinking. On the other side, they think that the human brain is doing the same thing. Is executing instructions. So if we look up this in the back of the book on chapter on Appendix C, it's going to say B means change the value of the program counter. Okay. So I have a program counter that's going to be change. Well, what is going to be changed? This part, the operand identifies the register to be compared to 0. So I'm going to look at the register number 2. If the value of register number 2 is equal register 0, I'm comparing 2 registers, then I'm going to put this address in program counter. Otherwise, 16 is going to be added to program counter. So this is the way it's going to go. Let's see if we can go over this together. So when I start my program, I'm going to be pointing to the top of my program. This is the main memory section that my program is going to be sitting. Once again, this is going to be 16-bit machine, so it's going to pick up 2 bytes at a time. Everything is being saved in the memory as 1 byte. So I need 2 bytes to work with a 16-bit program that I have. The program counter is going to be A0. So A0 is going to have what? 156C. That's going to come in for my first instruction. This is my register 0, register 1 all the way to register F. So my first instruction is 156C. I want you to look in the back of your book, chapter appendix C. Tell me what is 156C means. 156C. What are we supposed to do? Appendix C. Load what? Okay. To what? So we're bringing the 156C in the instruction register. 156. Okay, when we put the 156C over here, our program counter is going to be pointing at the next one. Remember, this is a 16-bit machine, so it's going to go 8, 8, it's going to go to here. So my program counter is A2. This is my instruction set, 156C. So 1 is a load, so we're going to be loading register 5 with whatever is in the 6C, right? Is that what it says, 156C? Alright. Arithmetic, logic operation, and or XOR. So how do we do, and then we're going to talk about the rotate and shift, circular shift, logical shift, arithmetic shift. Okay, let me leave this one for Wednesday. We're going to go over this on Wednesday. So I think we had enough for you to sink in for today, and we're going to pick up from here on Wednesday. Any questions? Any concerns? Okay, so I'm going to stop right here.